I'm going to walk you through a design of a 2-input NAND gate. Okay, so here's my IC station schematic editor. Let's go to File, New, Schematic. We'll create a BU NAND. Alright, so I have a new schematic window. Let's go to ADK IC library. Let's bring in my VDD. Let's bring in my ground. I'm bringing my PMOS. Move this around. Let's bring in my 2 NMOS that needs to go in series. So I can move this down here. Okay. Alright, so I have all my PMOS, NMOS, VDD, and ground. So let's start wiring these up. Let's bring in an input. Let's bring in another input. Let's bring in an output. Okay. Alright, so we have the basic wiring all done. Now, next thing we need to do is to size the transistors correctly. And if you look at my handout, the size for the PMOS both need to be 12. The width needs to be 12. Okay. The width needs to be 12 on this PMOS as well. Both NMOSs also tend to have a width of 12 for the NAND gate. And why this is the case, we'll talk about in class. So let's set all the width of all 4 transistors to 12. Change the names of the inputs and the outputs. We call that A. Call the second input a B. And my output a Y. Okay, so I have my inputs A, B, output Y. I have my VDD. Oops. I have my VDD connection, my ground connection, PMOS both sides 12, NMOS is in series both sides 12. Okay, so I have my schematic all set. So the next step is to do simulation. Click on the simulation button. First thing we need to do is set up the model library. So click on libtemp inc, include files, browse. Up here type in $ADK under technology, IC, models, AMI05.mod, say OK. OK to this. Set up the library. Now we need to set up the forces. So let's start out by defining the VDD as being 5 volts. Highlight that. Click on forces, manager. This brings up a setup simulation window. So let's set up the forces first. We'll call VDD selected. Click on independent source, DC. We'll set up VDD of 5 volts. Okay. Click on the add button. Let's go back. Let's go back here. Now let's select A. Go back to the setup simulation window. On A, we're going to set up a pattern that goes 0, 1, 0, 1. So let's click on pattern. Change the high value to 5. Delay can stay 0, low value to 0. Rise time and fall time can stay the same, so can the pattern duration. So the pattern is going to run for 100 nanoseconds. Okay. Repeat the pattern. Go change the binary and add in 0, 1. Okay. So add a 1. Let's go back. Highlight B. go back, set up pattern again, leave everything the same as A except the pattern duration to be 2. Okay, so here we have A and B set up. So we have all the forces set up. Okay, now let's set up so that we can actually view the waveforms for A, B, and Y. So click on A while holding the control key on your keypad, highlight B and highlight the wire for a Y. Now go back to setup simulation, click on edit waveforms. All three should be highlighted. Under analysis, scroll to transition. Under task, plot, and everything is all set. Click on the plus. So we've set up our waveforms. So far we have the waveform inputs set up. We set it up so that we can view the waveform. Next thing, let's go and set up the simulation analysis. Click on analysis setup, click on transient, expand this, go to transient setup, start time can stay at 0, end time to 400, apply, analysis transient. Okay, so we're all set. So we've set up a transient analysis, set up the waveforms, and made sure that our output can be viewed. Now let's run ELDO. Okay, it says simulation completed successfully. Okay, so now let's view the waveforms. Go to view waves, click on new window, otherwise you might sometimes get an error, and wait for the waveform to show up. Okay, let's expand this. Here we have A, which goes 0, 1, 0, 1, B, which goes 0 and 1. Together they simulate the case of 0, 0, 0, 1, 1, 0, and 1, 1. And here's the output of Y of the NAND gate. The NAND gate is high when either A is 0 or if B is 0, but when both of them are 1, it goes low. So this proves that the NAND gate we created is functionally correct. Okay, so this is how you create a 2-input NAND gate and simulate it. So when you're done, click on end simulation. You come back to your original window and you can print the schematic and the waveforms from EasyWave.